Good morning, students. In today's lecture, we will discuss the concept of the d-value, also known as the decimal reduction time. This concept is very important in dairy heat processing because it helps us understand how quickly microorganisms are destroyed by heat. Let us begin with an introduction to the d-value. The d-value is considered a measure of the thermal resistance of microorganisms. It represents the time required to reduce the microbial population by one logarithmic cycle, which means a 90% reduction. This measurement is always determined under constant temperature and constant environmental conditions. In simple terms, it tells us how long we must apply heat to destroy most of the microorganisms present. Now let us define decimal reduction time more formally. The d-value is defined as the time required at a specific temperature to reduce the microbial population by 90%. Mathematically, this means the population decreases from 10 raised to n to 10 raised to n minus 1. The notation often includes the temperature. For example, d 72 degrees Celsius. This means the d-value measured at 72 degrees Celsius. Therefore, the d-value always depends on the processing temperature and conditions. Let us understand the concept of 90% microbial reduction. Suppose we begin with 1 million microorganisms. After 1 d-value of heat treatment, the population reduces to 10% of the original. This means only 100,000 cells remain. So the population decreases by a factor of 10. This is called 1 log reduction. Each additional d-value reduces the population further by another factor of 10. The d-value can also be expressed graphically from a survivor curve. In this graph, the logarithm of surviving microorganisms is plotted on the y-axis. Heating time is plotted on the x-axis. The survivor curve generally appears as a straight line on a semi-logarithmic graph. The d-value is the time interval between 2 points that differ by one logarithmic cycle. In other words, the time required for the population to drop by 1 log unit. This slide shows the relationship between the d-value and the survivor curve. The distance between two log reductions represents one d-value. The slope of the line indicates the thermal resistance of microorganisms. A steeper slope means microorganisms are destroyed more quickly. This corresponds to a smaller d-value. A flatter slope indicates greater heat resistance and therefore a larger d-value. The d-value can also be expressed mathematically. The survivor curve equation is log nt equals log n naught minus t upon d. Here, n naught represents the initial microbial population, nt represents the population after time t. From this equation, the d-value can be calculated as d equals t upon log n naught minus log nt. Another relationship links the d-value with the microbial death rate constant. K equals 2.303 upon d. This shows that a smaller d-value means a higher death rate. Several factors influence the d-value. First, temperature. As temperature increases, the d-value decreases because microorganisms die faster. Second, the type of microorganism. Bacterial spores are usually much more heat resistant than vegetative cells. Third, the composition of the medium. Factors such as pH, fat content, and total solids can protect microorganisms and increase the d-value. The d-value plays an important role in dairy heat processing. First, it helps in process design. Engineers use d-values to determine appropriate time-temperature combinations for pasteurization or UHT. Second, it helps maintain a balance between safety and product quality. Finally, d-values are used for process validation to ensure that the heat treatment effectively destroys pathogens. Let us look at a simple example. Suppose the d-value at 72 degrees Celsius is equal to 2 minutes. If we want a 3D process, this means 3 logarithmic reductions. The total processing time is calculated as time equals n into d. Here, n equals 3. Therefore, time equals 3 into 2 equals 6 minutes. This means 6 minutes of heating would achieve a 99.9% reduction. This slide summarizes the entire concept. The survivor curve shows how microbial population decreases over time. The mathematical equations describe the same process quantitatively. Practical examples demonstrate how D values are used in industrial processing. The key idea is that microbial destruction during heat treatment follows predictable mathematical behavior. To conclude, the D value is a fundamental parameter in thermal processing of milk. It represents the time required to achieve a 90% reduction in microbial population at a given temperature. Understanding D value helps food engineers design heat treatments that ensure safety while maintaining product quality. Thank you.